just to help everyone as they go through computing CLV for CDNOW, I thought I would go through all the calculations from soup to nuts so you can see everything coming together without any pieces missing. So I'm just going to kind of go through this hopefully pretty efficiently so that you don't have a really long video to go through. But effectively, again, the idea here is to take the transaction log data that we have and then use that in conjunction with the SEC data that we have to estimate CLV for different cohorts of customers that we can observe from the Q1 1997 cohort. So what I'm going to do is I'm going to quickly pull up the spreadsheet that we have. So again, the goal here is we want to first get our raw data, use that to effectively fill in this spreadsheet over here. The two pieces that I've kind of filled in for you are two of the pieces that we're going to kind of take as being given. So one of them is that the contribution margin is 19%, and the other is that the cost of customer acquisition is about $32.92. This goes through the figures that we used to calculate that CAC figure. Again, this was pulled from the income statement data that we had, where we were able to get both sales and marketing expense and the number of customers that were acquired within that period of time. Now in the spreadsheet that we had used, we had put in an annual discount rate of 12%. In the slides, we used a number of 11.5%. I would give full credit for both of those, but I'm just going to put in 12% here. But the key, the really hard part, is how do we get these values for the probability of customer activity over time, the frequency while customers are active, and the average order value. So again, step number one is going to be to fill in this data, and then we're going to use models to get estimates for the evolution of these other variables as a function of customer tenure. So I'm going to pull up right now the Shiny app, log in, and I'm going to include the data set that we have over here. So let me just go transaction log CDNOW. Now the example that we did in class was the January 1997 cohort, so I'm going to focus on those. One super quick comment over here, the data that we have, it's for the Q1 1997 cohort, and that is why when we look at total monthly sales, there's kind of elevated sales for those 3 months and then it kind of goes down. It's not because sales went down that hard at CDNOW as a whole, it's just that we're only looking at data for customers that were acquired within these 3 months over here. So this is just natural cohort level attrition for those cohorts. So again, we have all of these charts that we've seen before. This is not surprising because we only see initial purchases for people within those 3 months. And all of the data is coming from the same source because we don't have any source data, and so it defaults to showing the total figures as a result. So I'm just going to go over here to the one cohort across customer tab, and I'm going to go to the January cohort. So again, for the homework, you'd be doing the February cohort. But for the January cohort, we see pretty strong amount of customer concentration actually. But the data that we need is the data coming from this table over here. So I'm going to copy this. Again, we don't have the profit data directly in the transaction log. We don't have transaction level profitability. So I just kind of copy that and pull that over here. And for the contribution margin, we separately kind of deal with that by effectively pulling that off of the income statement and just assuming that it's static over time. So let me just blow up these columns over here so you can see them a bit more clearly. For this one, I'm going to convert it from, on the scale of 100 to a percentage. So I am just going to do this. And I'm going to start by modeling this process, and then I'm going to move to the other two. So P active, we can see these values have been automatically referenced over here. They're pulling from the right place, so let's just make sure 6.350, 6.350. Yep, so we got a match over here. Feeling good about that. We're doing the simple two-segment model to do this estimation. So let's just put in a couple of values over here just to get us started. Imagine that the probability you're in segment number 1 is 10%. If you're in segment 1, you've got a 3% probability of churn in a given month. And I'm just going to initialize P2 at 15%. If those values were true, then this would be the retention curve for the good segment. This would be the retention curve for the bad segment. This would be the overall retention curve, which is taking a weighted average across the two. These are the sum of the squared errors over here. And so what we're going to do is we're going to sum all of those squared errors, and we're going to find the parameters that minimize the sum of the squared error. So solver, make this as small as possible by changing these three parameters and making sure that they fall within these constraints. Feeling pretty good about that. Now that we've got that fit, now we can copy and paste this on down over here, like so. And, you know, I mean, looking at this data, this seems like a pretty sensible trajectory for retention into the future. So P active, done. Frequency. This is also updating from this tab over here. It's this column over here. As we would expect, all these values are greater than 1, because if you're active, that means you made at least one purchase. And as we said in class, what we're going to do is we're going to run a regression. The Y values are here. Note that we're using all the data. The X values are here. And let's put the output over here. Good. And you can see here our expectation of frequency is simply the intercept plus the time variable multiplied by our coefficient associated with time. Doesn't seem unreasonable to me. And so we can take this out as far as we would like to as well. So I'm just going to take this out, call it 60 months. Whoop. There we go. Okay. Next up is AOV. This is similarly already referencing data from the raw data tab. So I'm just going to do the same thing as before. Same thing as what we did for frequency. Regression, our Y's are over here. Our X's are over here. Again, we're using all the data, including month 0. Output range will be this. And when we run our model, seems again pretty sensible to me. So let's just take this out a bit further. Okay. CAC we've got. CLV. So the main thing that we want to make sure to do is we want to have actuals whenever actual data is available, and then we move to the model. So one thing you could do is you could just go to this tab. This is using VLOOKUP, which is totally fine. But you could also similarly, imagine if we just copied and pasted the values over here. We could go over here and simply special paste transpose, and that would effectively do the same thing. So we've got actual data up through month number 17, so it's over here that the model starts, and you can see, helpfully, this is already using the formula to get the expected future activity retention, and it's pulling the parameters directly. So, and we can see this is going to go out 60 months. So let's just very quickly do the same thing for frequency while active. I can simply copy this, go over here, transpose, and then same for AOV, copy, transpose. I'm just going to keep the formatting consistent, making sure that this is computing correctly. Usually the way that I'll sanity check that is I will look at the resulting long-range projections over here. So this is again the first 5 years, and we can see all these ups and downs. This looks like actual data, and then we see the model. Same thing for frequency, same thing for AOV. So there's nothing that seems amiss to me from this. Now again, this is assuming that we have AOV go flat at 48 months. Doesn't really matter. Let's put it at 60 months. But again, if we had other situations where a lot was riding on growth in AOV that we didn't feel comfortable with, then we can use that to flat it out. So revenue per cohort member in any period is the proportion of the cohort that's active in that period times the frequency while active times the AOV. So we've got this resulting profit per cohort member when we scale it by the contribution margin. These are our discount factors. It's all being computed properly. We see the PAV is on the order of $30.77. CAC is about 33, and so the CLV is negative. Now you may say, well, we're stopping at 60 months. Maybe we should go out further than that. Well, you could. Let's go out, as far as you want. Let's go out an additional 250 periods. Whoop. Let's do that one more time. And here we go. $250.